So the last section in this chapter that we're going to cover is chapter 11.5. So we're going back a couple sections to do partial fraction decomposition. This is mostly used in solving differential equations, and it's an important part for calculus. So we need to be able to see this. So it's kind of a review of your algebra skills and kind of putting all of this year together. So let's go back to freshman year for a second and say, add these two fractions together. So in order to add these two fractions together, we need a common denominator. This needs an x minus 3, and this needs an x plus 4. So we're left with 3 times x minus 3 plus 2 times x plus 4, all over the common denominator, x plus 4, x minus 3, right? So now we distribute this, that's 3x minus 9, and this is 2x plus 8. So that leaves us with 5x minus 1 all over x plus 4, x minus 3. So we can add two different fractions together and we get the composite of the two, right? Well, what if we were asked, given this polynomial, this rational function, I want to separate it into its different associated pieces. And that's what partial fractions is. We're taking this big fraction and we're breaking it down into the sum of its parts. So we're going to talk about 3 different cases, and we're just going to do a couple example problems. We'll do a couple problems in class as well, just to kind of exemplify this, because it's not that straightforward. So for case number 1, assume that Q has non-repeated linear factors, which means we factor the denominator. This is also assuming that we have some rational function P over Q. So if our denominator has non-repeated linear factors, then we decompose the fraction as its sum of its pieces. So we'll take each linear factor and we'll write it over a different coefficient. So the best way to exemplify this is with a problem. So let's write out the partial fraction decomposition here. First, we need to factor the denominator. So simple factoring, multiply to 6 to add to negative 5. So that's x minus 2, x minus 3. Equals. We have 2 distinct linear factors. So I'm going to write the sum of its pieces, x minus 2 is 1, plus b over x minus 3. Here are 2 pieces, and what we do is we're going to clear this fraction out. We're going to multiply both sides by the denominator. So we're going to multiply everything by x minus 2, x minus 3, and we're going to solve for a and b. So on one side we're left with x equals, well, we have a times x minus 3 and b times x minus 2. So now if we're just going to do a little bit of algebra, distribute the a, we have ax minus 3a plus bx minus 2b. Now I'm going to regroup these together. Remember, it's all equal to x. So the ax and the bx, I'm going to write x, and I'm going to factor out the a and b, since they both have an x. And likewise, I have a negative 3a and a negative 2b. So I'm going to have this number here plus negative 3a minus 2b. So we can do this algebra. We can group each piece together. And I'm going to write something over here. We have an x term on both sides, and we have a number term on both sides. In order to solve, we're going to set the coefficients of the x equal to the coefficients of the x on this side. So we have 1 equals a plus b. And the second one, we have negative 3a minus 2b equal to 0, because we don't have a constant term on the left-hand side. So 0 equals negative 3a minus 2b. Now we just have a system of equations. We have 2 equations, 2 unknowns, and we're asked to solve. So I would just as easily solve with substitution or elimination. I know that 2b equals negative 3a, or b equals negative 3 halves a. So I can just plug that in. I have 1 equals a plus a negative 3 halves a. So this is 2 halves negative. So 1 equals negative 1 half a, or a equals negative 2. If a is negative 2, all I do is plug that in here. I have b equal to negative 3 halves times negative 2. Those cancel, those cancel. B is equal to 3. So a is equal to 2, b is equal to 3. I can now write out this partial fraction as negative 2 over x minus 2 plus 3 over x minus 3. Our partial fraction decomposition for this problem all turns into, we break this problem into this one. So, moving on, flip the page over. So next up, the next type of case that we could have is if we have repeated linear factors. So that means if we have a partial fraction and we have anything of a quantity squared in the denominator, we're going to have to write it out multiple times in order for it to be represented. So the way you read this is it says if we have a polynomial q has repeated linear pairs, say x minus a to the n, then in the partial fraction decomposition, we're going to write a over x minus a plus some different one over x minus a squared plus until we show all of the repeated factors. So again, the best way to exemplify this is through a practice problem. So first off, I want to factor the denominator. So I have x plus 2 over, I'm going to factor out an x, and I have x squared minus 2x plus 1, which this can be factored. That's the sum of, or the difference of a perfect square. So this factors to x plus 2 over x times x minus 1 quantity squared. So this is the fraction that I want to separate out. So I'm going to write my first one, which is a over x. That represents this piece of the denominator, plus b over x minus 1, because that's one of my linear factors, plus c over x minus 1 squared. Because this repeats, I write it until I end the repeat. If it was x minus 1 cubed, I would have another term. So each of these coefficients gives me each piece of this partial fraction decomposition. So again, now you clear the fraction completely. So that leaves you with x plus 2 equals, well, I have a times x minus 1 squared plus the second term would just leave you with b times x minus 1 plus c times x. So there's a couple ways to do this. We can go to a system of linear equations, which is fine. We can get 3 equations and 3 unknowns. We're going to have x squared, we're going to have an x, and we're going to have a 0, or a constant term. Or the way that the book explains it, which is a little different, we can say, well, what if x was 0? What happens if x was 0? Then this term would go away, and this term would go away, and all we're left with is ax, a times negative 1 equals 2, because that would be 0. So if we said if x equals 0, then you'd have 2 equals a times negative 1 squared. The b would drop off, the c would drop off. So then a has to be a has to be 2. Likewise, if you did the exact same thought experiment and you said, why don't we let x be 1? If x equals 1, then the a term drops off, and the b term drops off, because that makes that 0, and we're just left with c of x. So we're left with, if x is 1, we're left with 3 equals c times 1. So c equals 3. So that just leaves you, now we know what a is 2, c is 3. We just plug those back in. We are left with x plus 2 equals 2 times x minus 1 squared plus b times x minus 1 plus 3x. Let's get that on screen. So that makes our lives a lot easier, and all we have to do is simplify this algebra. So to simplify this algebra, all we have to do is pick a number. Pick a number that's not 0 or 1. So if we pick 2, if I pick 2, I have 4 equals 2 times 1 squared plus b times 2 times 1 plus 3 times 2. So this is just 2 plus 2b plus 6 equals 4. Well, that's really easy to solve. 2 plus 6 is 8. Subtract 8, I have negative 4 equals 2b, or b equals negative 2. So there's our a, our b, and our c. So that means our partial fraction decomposition is 2 over x plus negative 2 over x minus 1 plus 3 over x minus 1 squared. I'm going to do this slightly different way. This is a pick the zeros, see if terms cancel out. I'm going to do the exact same problem, just starting from right here. So another way to solve example 3, and I'm just going to write example 3 right here. So once we get to this step, x plus 2 equals a x minus 1 squared plus b times, I'm just going to FOIL that out a little bit, x squared minus x plus c of x. What I want to do is multiply all of this algebra out and group the like terms. So I have x plus 2 equals, this is ax squared minus 2ax plus a, that's that multiplied out, plus bx squared minus bx plus c of x. So now I have x squareds that I have to group together, I have x's, and I have just a number. So I have x squared, and then what are my things attached? It's a plus b plus, where are my x's? I have negative 2a minus b. Those are my ax, plus c. Those are all of my x's. That's the a term, that's the b term, that's the c term. And then what's left? Plus a. And what's that equal to? I have x plus 2, which is a 1x. So you have 0x squareds, you have 1x, and you have one number, which is 2. So we set the x squared terms, a plus b, equal to 0. You set the second one, negative 2a minus b plus c is equal to 1. And you have your last term, a equal to 2. There's your x squareds, there's your x's, there's your a. Here's your system of equations. You have 3 equations, 3 unknowns. You have a plus b equals 0, negative 2a minus b plus c equals 1, and a equals 2. So you could solve this system just like we did before, and we're going to get a equals 2, we're going to get b equals negative 2, and we're going to get c equal to 3. This method will always work. The guess and check method, not so much. So we're going to use the same type of setup to solve the next couple ones. So for example 4, it's already factored for us, but we can look at it and we're like, okay, we need to decompose this. We have x cubed minus 8 over x squared and then x minus 1 cubed. Ugh. So I'm going to have a over x plus b over x squared plus c over x minus 1, there's my first one, plus d over x minus 1 squared plus e over x minus 1 cubed. So this is the partial fraction expansion. We're going to have 5 equations and 5 unknowns in order to solve for this, which looks kind of messy, and it kind of is messy. But what we want to do is at the very least, we can multiply this all out. So let's clear the step one. Step 1, we write out the expression. Step 2 is clear the fraction. So what happens when we clear the fraction here? We are left with, I'm just going to write equals here. We have a, we have x times x minus 1 cubed plus b times x minus 1 cubed plus c times, well, c gets an x squared and an x minus 1 squared plus d, d gets an x squared and an x minus 1 plus e, which is just x squared. So the way that we are going to work this out is pure algebra, and we're going to get 5 equations and 5 unknowns. So I'm just going to grab a separate sheet of paper and expand out each one of these, and then we're going to group the like terms. So for this first term, if I multiply out the x minus 1 cubed, I have x cubed minus 3x squared plus 3x minus 1. So that gives me a times x to the 4th minus 3x cubed plus 3x squared minus x. That's my a term. For my b term, it's just x minus 1 cubed. So my b term is b times x cubed minus 3x squared plus 3x minus 1. My c term is x squared times x squared minus 2x plus 1, which would be c times x to the 4th minus 2x to the 3rd plus x squared. My d term, if I look here, my d term would be x cubed minus x squared. And my e term is just x squared. So this is everything that's written up here, just multiplied out. So I want to see everything that has an x to the 4th. I'm going to have my x to the 4th terms. A has 1, B doesn't have any, C has 1. So I have A plus C plus my x cubed terms. My x cubed terms, which ones have x cubed? So A would be negative 3A. My B's would be 1B. My C's would be negative 2C. My d's would be 1d, and e doesn't have any. My x squared terms, so I'm going to write that the next line. My x squared terms. A has 3x squareds. So my x squared is 3 a's. My bx squareds is minus 3b. My cx squareds is plus c, 1c. And my dx squareds is negative minus d. And my ex squareds is 1. Which ones have x's in them? So x is negative 1a, so negative a. B has 3 b's. C has how many x's? C has 0 x's. D has 0 x's, and E has 0 x's. And my last one are my e's, or my numbers, so plus my constant. So I'm just going to say 1. Which one has a constant? A doesn't have a constant. B has a constant, so that's negative b. C does not have a constant. D doesn't have a constant, and E has a constant. Okay, so this is all of my systems of equations. I have a plus c. I have negative 3a plus b minus 2c plus d. I have 3a minus 3b plus c minus d plus e. I have negative a plus 3b, and I have negative b. So what are these all equal to? Well, I go back to my original equation, which I'll bring back here. How many x to the fourths do I have? 0. How many x to the thirds do I have? 1. How many x squareds? 0. How many x's? 0. How many numbers? Negative 8. So right off the bat, I already know that b equals 8. So that's helpful. But the nice thing, I have a system of equations, right? Solve using matrices. Now, you guys did this by hand. My honors kids did this by hand. Everyone else used a calculator. I'm going to show you once how to use a calculator here. This is 5 equations, 5 unknowns, and we're going to do A inverse times C equals our variables. So, I want to go to, let's just zoom in right here. I go to calculator. I want an inverse, so the button right next to 9. Hit that. I want a 5 by 5 matrix. Okay. So my matrix for my first row, first column, would be 1, 0 B's, 1 C, 0 D's, 0 E's. My next one would be negative 3, then 1, then negative 2. Make sure that I type that in right. Negative 2, then 1, then 0, because I have 0 E's. My third one, my third equation, my coefficients are 3, negative 3, 1, negative 1, 1. My fourth equation is negative 1, 3. There's 0 C's, 0 D's, 0 E's. My fourth one is 0, negative 1, 0, 0, 0. And I want the inverse of that, so I hit the caret, which gives me my exponent to the negative first, and I do times. I want to go to menu, hit enter, and I want a 5 rows by 1 column. So that's a 5 by 1. Now, we put in the coefficients here. So my coefficients here are 0, 1, 0, 0, negative 8. If I typed everything in right and I hit enter, I should get my coefficients for my variables. So how do we read these? Well, let's go back to our paper. here are all my coefficients. A is 24, B is 8, C is negative 24, D is 17, E is negative 7. So let's just rewrite those on the piece of paper. I'm going to flip this back over and go back to our notes. Zoom out just a little bit for you guys. I found that using the calculator, A equals 24, B equals 8, C equals negative 24, D equals 17, and E equals negative 7. So that means our partial fraction decomposition would be 24 over x plus 8 over x squared plus negative 24 over x minus 1 plus 17 over x minus 1 squared plus negative 7 over x minus 1 cubed. So a lot of work just to expand out this simple expression. We have one more case to talk about, and then you'll be good to go. The last case that we have is if the denominator contains irreducible quadratic factors. So we cannot factor this quadratic without getting imaginary factors. If that's the case, each time that happens, we write, instead of a on top, we write ax plus b, or cx plus d. Again, the best way to exemplify this is with an example. So before you do anything, you need to factor the denominator. So we have 3x minus 5. Factor the denominator, that's x minus 1. Square the first, multiply the 2, change the sign. So x squared plus x, square the last, plus 1. So this is our x cubed factored. X cubed minus 1. That's the difference of two cubes. So how do we expand this out? Well, our first linear term is a over x minus 1, like we do, plus our second is a nonlinear quadratic. So we write bx plus c over x squared plus x plus 1. Now, everything else is the exact same. So we wrote out our partial fraction. 2, we're going to clear this fraction out. So that leaves me with a times x squared plus x plus 1. And then we have plus bx plus c times x minus 1. This gives me another quadratic. And that's equal to 3x minus 5. So let's multiply this out. This is ax squared plus ax plus a plus outer bx squared inner, or let's FOIL it, minus bx plus cx minus c. Now we just group the like terms together. So we have our x squareds, that's a plus b, plus our x terms. So we have an a minus b plus c, and we have our last terms. So we have a minus c. So our three equations, we're going to have 0 equals a plus b. We have 3, which is the coefficient here, equal to a minus b plus c. And our last one is negative 5 equals a minus c. So however you want to solve this, whether using your calculator or likewise, I'm going to show you how to use your calculator. You could easily solve this by hand, right? So in order to solve this using matrices, we go menu, get our, we want 3 equations, 3 unknowns. So we have 1, 1, 0, 1, negative 1, 1, and 1, 0, negative 1. We want the inverse of that times a 3 by 1, so 3 by 1, which is 0, 3, negative 5, if I typed everything in right, I get my 3 solutions. If I did this by hand, I'd be afraid because I get fractions. So A is negative 2/3. B is 2/3. And C is 13/3. So if I wanted to go back here to write my partial fraction out, that would be negative 2/3 over x minus 1 plus 2/3 x plus 13/3 all over x squared plus x plus 1. This is our partial fraction decomposition of our original function. We have one more, and then we'll be good to go. All right, example 6. Write out the partial fraction decomposition here. Well, looking at this denominator, we have irreducible or nonlinear quadratics, and it's squared. So what we're going to do is we're going to repeat those factors just like we did before. So we have x cubed plus x squared over x squared plus 4 squared equals, well, our first term is an irreducible quadratic, so that's an ax plus b over x squared plus 4. Our second one plus is going to be a second one, cx plus d over this squared. We repeat it twice so that this is going to clear the denominator. So let's write this all out. Clear the fraction, so we multiply everything by x squared plus 4 squared. So that leaves me with x cubed plus x squared equals ax plus b times x squared plus 4, and then we have plus cx plus d. Let's say that's d, because this whole thing cancels out. Okay, so now I only have to do one multiplication. So I have ax times x squared, ax cubed, plus 4ax, plus bx squared, plus 4b, plus cx, plus d. So let's just group these. I have 1 equals a. 1x cubed equals 1ax cubed. Okay, that's nice. How many x squareds do I have? I have 1 equals b. Well, that's nice. I have 0 x's, so my third one would be 0 equals 4a plus c. And then my last one would be 0 equals 4b plus d. That takes care of all of these terms. I know a equals 1, I know b equals 1, so that means c equals, if I plug 1 in here, it's negative 4, and that also means that d equals negative 4. So my expansion is going to be, if I went up back here, it's going to be 1x plus 1 over x squared plus 4 plus, you don't have to write the 1, by the way. C is negative 4x minus 4 over x squared, let's see if I can write this all out, plus 4 squared. So that is partial fraction decomposition. I know we'll probably do a couple more examples in class, in person, and hopefully it'll help you out, clear things up a little more. All right, take care.